Okay, in this next section, we are going to use sigma notation, which we saw in pre-calculus. So remember, it's the sum from I is equal to 1 to n of your AI terms. The key thing that we want to make sure everybody's aware of is that this I is going to be your index of the summation. So what will happen is inside of the summation, you will have terms that depend on that index. Now, when you're looking at a finite sum, there are two key rules that we want to remember. The first is the sum and difference rule that says that we can split up a summation if we're adding and subtracting. And then the second rule is the constant multiple rule. And we want to remember that that tells us that we can pull out the constant. And when we're talking about a constant, it is going to be anything that does not depend on the index. So if you have anything that does not depend on the index, that is going to be a constant that you can pull out. So those are two key rules, sum and difference rule and constant multiple rule. Now, also in pre-calculus, we had summation formulas. And you'll want to earmark this page because we're going to come back to these summation formulas later on. But the summation formulas are important because they allow us to remove the sigma notation. So basically it's our way of getting rid of the sigma notation. So to remove that sigma notation, we use these summation formulas. So you'll notice, like if you look at this first one, that would be the summation of a constant. So a constant C is going to be C times N. So for example, if you had a summation from I is equal to 1 to M of 5, your C value would be 5, and then this would become 5 times N. Okay, so by a similar token, if you have the sum of all the i's from I is equal to 1 to n, it will become n times n plus 1 over 2. So these formulas we're going to use in our calculus work here. But before we get to the calculus work, what I want us to do is just go through a quick pre-calc example of how you work with sigma notation. So they have the summation here, and the first thing you want to ask yourself, is this n squared a constant? Now remember, a constant is anything that does not depend on the index. So when you look at this summation that we have, our index is equal to I. And so n squared is not I in any way. And so yes, this is going to be a constant. So the n squared is a constant. And because it's a constant, we can pull out the constant from the summation notation. So basically what I do in this next step is I take this n squared and I pull it out in front, and that gives us 1 over n squared. Now of course it does become a 1 over n squared because originally it was in the denominator, so we need to put a 1 over that n squared. Okay? So we pull out the constant, and what we're trying to do here is we're trying to get this into one of the formats of I squared, or I cubed. And so once I pull out the constant, I then am going to look at the summation, and I'm going to split it into the sum of the I terms plus the sum of the 1 terms. So this is going to split the sum. And then once I have the sum split, then I notice that I have a summation of all i's, and we know from our formula at the top here that the summation of I will go to n times n plus 1 over 2. So this summation of the i's goes to n times n plus 1 over 2. Meanwhile, we also have a summation of 1. And when you have a summation of 1, that is as if C is equal to 1. So if you plug in C is equal to 1 into this formula, you're going to have the summation of I is equal to 1 to m of 1. So C is equal to 1 times n. So this will just become n. So in this last step here, I'm using these two sigma notation formulas, the sum of the c's, the sum of the i's, to get rid of the sigma notation. And then once I have that sigma notation removed, then I can simplify from there. Okay, so we're going to use those two ideas of sigma notation in this next section to deal with the calculus part of finding the area under the curve.